This is the 1981 Texas Instruments TI-99 4A home computer console. It has an aesthetically pleasing aluminium or aluminum case finish. However, ours has sustained some damage at the rear. So let's open it up, fix what we need to, and apply some modern magic to the world's first 16-bit home computer. On the underside of the computer, there are 7 screws securing the case to the base. Slowly lifting the case, whilst being careful with the front right power sliding switch, the rear power supply connector, and all whilst securing the 7 retaining screws. On the underside of the case, we can see the rear of the power supply and the keyboard circuit. Taking a closer look at the power supply by removing 2 retaining screws and lifting the power supply circuit up, we can see a connector with 4 brown cables which disappear into the metal housing. Slowly lifting the metal housing reveals a ribbon connected to the keyboard, so by carefully disconnecting this, we can finally remove the metal housing for further inspection. Removing the 2 metal edge clips, presumably to ensure ground connectivity across the metal housing, and removing the retaining screws from the top of the metal housing and carefully securing the ROM cartridge right-angled edge adapter. It was time to remove the top and base of the metal housing to reveal the motherboard. So we've got 16K of system RAM, the input and output management chip, the video processor, which interestingly has this large metal heatsink which actually made contact with the metal housing, as we can see here. So this chip must be a real workhorse. We have a 16-bit processor running at 3 MHz, which interestingly doesn't have a heatsink. The sound generator can simultaneously produce sound from 3 square wave tones and 1 noise generators. There are 3 6K graphics ROMs, 2 128 byte RAM chips totaling 256 bytes, and the 8K system ROM. Now we've seen the RAM and ROM chips, let's see how memory is managed. From the top, we can see 8K of fast system ROM used to run the computer. Space for an 8K RAM expansion using the 8-bit bus. 8K for peripherals. 8K cartridges such as games. A fast 256 byte scratch area, proxy access to mapped devices by providing the address and data to be read or written, and finally a second RAM expansion area which allows an additional 24K of RAM. One question though, where is the 16K of system RAM? Surprisingly, this is addressed indirectly via the video processor RAM read-write address, which means this is highly inefficient and why TI Basic is considered notoriously slow, and is probably the reason for this massive heatsink. Having removed the 4 screws securing the keyboard to the case, a closer inspection reveals this to be clean and tidy, with the keys appearing to work perfectly. As a result, this should only require a light clean. Moving back to the motherboard, let's clean both sides on that edge connector and those keyboard pins with rubbing alcohol. And applying contact cleaner to the ROM cartridge port, the cartridge right-angled edge adapter, the cassette tape connector, the video DIN connector, and the joystick port interface. The aluminium or aluminum case is in really good condition, apart from this dent at the rear. Looking at the inside of the case, we can see a spring-loaded mechanism which operates the ROM cartridge door, and next to that a multitude of aluminium or aluminum tags which, when twisted, allow the rear trim to be removed. This also gives us the opportunity to perform a light internal and external clean. Having secured a second non-working donor TI-99, I identified this unit had a few cosmetic differences, notably a raised static keyboard reference strip and a plate leading to the ROM cartridge port labelled Solid State Software, whereas our restoration unit has an open keyboard plinth with separate removable keyboard reference strips and no plate on the ROM cartridge runway. Looking at the base of the donor unit, there was a serial number which was R045734, followed by 4083 RCI. Having checked this detail, the R meant it was a reconditioned unit and was originally assembled during October 1983 in Riete, Italy. Revisiting the restoration unit, the label only advised it was assembled in Italy. In an effort to identify the serial number and status of this restoration unit, I removed the label, which revealed, well, nothing. As a result, I went over the motherboard again to locate the oldest dated chip, which was February 1983, which means our restoration unit appears to be a cost-reduced, earlier revision unit. Having opened the donor unit up, twisted the aluminium or aluminum fixings, removed the ROM cartridge mechanism to gain access to the final fixings, I carefully removed the rear trim before successfully fitting securely to the restoration unit. This is the Texas Instruments power supply, which was also made in Italy during what appears to be week 12, so March 1983. The output voltages are listed as 16 and 8 volts alternating current. And although the power receiving connector has 4 pins, only 3 of these are wired up to the power supply board. Reviewing the internal power supply board, we can see 3 outputs, +5, +12 and -5 volts direct current, which go directly to the motherboard, and from a block diagram perspective looks like this. As the power supply at the time of writing this review is over 40 years old, it's not something I would trust to reliably power anything. So clearly we need a modern alternative. This is the RetroPower PSU, the high quality modern alternative from Poland for powering retro computers. This one came with a pre-configured DIN connector, which is cabled to a 3D printed TI-99 4A compatible 4-pin adapter, thus repurposing the existing console computer power connector and bypassing the internal power support board. Let's repurpose the receiving power connector, the internal power board connections, prepare them for soldering, add an additional power cable to the receiving power connector, hot glue it for strength, and solder the new configured receive power connector to the internal power connectors on the motherboard using insulating piping and electrical tape to secure the newly configured cabling to the RF metal housing. And from a block diagram perspective, looks like this. To maintain all modified parts, let's tape the original connector to the inside of the case and secure the original internal power supply board using the 2 original retaining screws. And to ensure we don't connect an original 16 and 18 volts alternating current power supply, let's emboss a retro style label to place under the original but now newly configured power supply connector. By default, the TI-99's European video output from the 6-pin DIN connector is component. However, using this encoder, it converts the signal to UHF, or ultra high frequency. Inserting the DIN plug into the TI-99 and the modular UHF cable to a period correct black and white mini CRT, and connecting up our new RetroPower PSU to the TI-99, the moment of truth arrived. Had our modern power supply mods worked, and will the TI-99 power on? And because we've bypassed the internal power supply circuit, we turn it on from here. Success! And the tuning marker on the right hand side confirms it's channel 36. To convert our component video to something a modern monitor can handle, I'm using this new cable from Cool Novelties, which splits the 6-pin DIN into separate luminance, red minus luminance and blue minus luminance component and audio. And using this modern USB powered component to HDMI converter, let's connect it up to a modern screen and see what happens. Oh, nothing. Okay, let's try another option. This near-retro digital video converter and scaler. As it uses BNC connectors, let's add some RCA phonos. Connect up the input component cables, the output VGA or video graphics array connector. And for the sound, let's convert the RCA phono from male to female and merge the signals to mono and give it a test. And it works. Let's get something loaded from this selection of original cassette tapes. But first we need another modern cable. The DE9 pin, tape to input, output and remote jacks. Connecting up this 1978 retro Marantz Superscope CD330 cassette recorder, let's offer the tape to the recorder and on the computer, jump into BASIC, and with the alpha lock key pressed down, type old CS1. Blast It, which was written by Ian Godman, has 5 devices which you need to disarm in sequence using the wire-guided robot within the time limit. As these were written in BASIC and use that proxy RAM we discussed before, I've sped things up a little bit. Written by Colin McCauley, allows you to score points as you collect potatoes without getting caught in the shadow cast by the setting sun or falling into your own trench. I mean, who'd do that? Oh. And finally, Core, written by A. Thomas, where you need to dodge left and right to avoid birds, clouds, aircraft, then through some caves, and then finishing up in a 3D maze. Let's move on from magnetic tape to solid state, where games bring their own RAM with them. Choosing the Car Wars cartridge and sliding it up the runway and with a light push to connect. Car Wars was written by Jim Dramis and published in 1981 and was a clone of the 1979 arcade game Head On, where you navigate a car through a grid to collect dots whilst avoiding the other car by changing direction. Also written by Jim Dramis and Paul Urbanus, published in 1982, is a space horizontal scroller shooter with the objective of destroying all enemy ships whilst avoiding objects, the ground, and overheating your laser cannon. Like many other retro computers, the TI-99 4A also has the ability to manage programs using modern high-capacity media. In addition, a flash-ROM 3D printed case is available from Thingiverse, which I downloaded, printed out, and using Rust-Oleum paint sprayed the base black and the top silver to match the TI-99. As the TI-99's joystick port is not Atari compatible, I also purchased this joystick adapter so I can use my retro joysticks. In summary, it reconfigures the TI-99 pinout to the Atari standard by mapping joystick directions, fire, and most importantly, pin 7 to the joystick's grounding connection. Using this method, we can configure a second joystick using pin 2 as the ground connection. However, we'll make do with the single joystick adapter for now. It's now time to play some of my favourite games from the internet. So, first up, let's choose Arcturus. No, wait, Arcturus is a 24K game, so we need another modern mod. In this case, it's the 32K sidecar memory expansion card. I also painted the base black and the top silver to match the TI-99. Having lifted the interface slot and located the 32K memory expansion, let's have a look at the memory map again to see what we've added. Interestingly, this RAM expansion is split into two: 8K low memory RAM from address 2000 and 24K high memory RAM from address A000 to form a total of 32 kilobytes of RAM. Right, back to Arcturus. Bill Buys published his Behemoth Zaxxon type 3D diagonal shooting game in 1983, which remains a real showcase of the TI-99's capabilities using these modern mods. Sticking with 1983, Nice Soft released this amazing tennis simulation, so let's take a look. In 1984, Pole Position was released, and given the resources available, wasn't a bad conversion. Although I wouldn't expect a light touch contact with another car to result in a massive explosion. And finally, a later game from 2008 called Neverlander. This beauty operates really smoothly with a basic but effective score in the background. Unbelievably, your own internet browser can now be used to emulate the TI-99 4A. Head over to JavaScript 99er for your retro fix, plus loads of additional utilities such as real-time assembly debugging and monitoring toolkits. It's all just amazing. Thanks for watching.